Hey, what's up? Welcome to this new video. This one is paper 1-3 of October-November 2010. This is of course A-level math. With that being said, let's move on to question number 1. So here we have to find the term independent of x, which means the term where there's no x, 0x. So let's see what can we do. So we have to expand this, for example, and the way you will expand this usually, we have the power 9, you will write 9, combination, something we don't know, and the first term is x, and this will be minus 1 over x squared. Now, if this is n, this will be n as well, and this will be 9 minus n. So we have to choose n in such a way that you will not have x in the term. So let's think, what can we choose? Again, this is done by trial and error. The value of n can be, from n can be 0, 1, 2, 3, until 9. So you can choose n among those numbers so that when you expand this term, there will be no x. So let's think. This is done by trial and error, obviously. So right now, I don't know what it is. I will try and see what is possible. So 9 combination, then we have x here, minus 1 over x squared. So I think because here we have x squared, so here we have 9, so 9 is what? 9 could be, let's choose, if we choose 6, for example, here, that will be 3. That makes sense. If you choose 6 here, so that will be 3, then that will be 3, because in total I have to be 9. So now if you expand, again, this is done by trial and error. I did not know this. I just thought about trying this, and it happens to work out. So 9 choose 3 is 84. Now again, if you don't know how to choose that, you can always expand everything, right? And then choose the term which has no x. Here you have x power 6, and that will be minus 1, this, and that will be x power 6. So this and this will cancel out, so obviously you will have minus 84 will be the term without x, or independent of x. Let's move on to the next question. The points A, B, and C have coordinates 2, 5, 5 minus 1, and 8, 6, respectively. Now, part 1, we have to find the midpoint of AB. So pretty easy. We use the formula we know, which is x1 plus x2, that will be 7, divided by 2 should be 3.5. y1 plus y2 should be 4, divided by 2, that should be 2. This is the midpoint of AB. Now, part 2, we have to find the equation of the line through C, which is perpendicular to AB. So pretty easy. For example, we have a line AB here, right? Now we know that the line needs to be perpendicular, means have to be at 90 degrees to AB. And the passing point is through C, so let's say C is somewhere over here. So we have a passing point, and we need to find the gradient of the line, so we can find the equation. So now we understand that the equation, the gradient of this line, to find that we have to first find the gradient of AB. So let's first find the gradient of AB. Pretty easy. y2 minus y1 over x2 minus x1. That should be minus 6 over 3. That should be minus 2. So conclusion, the gradient of the line will be half. So here we have the gradient, we have the passing point C, which is 8, 6. That is x value, y value. We can find the equation pretty easily. So y minus 6 over x minus 8 should be half. Then we can cross multiply, that should be 2y minus 12, x minus 8. So 2y will be x minus 8 plus 12, and that should be 2y is equal to x, that should be plus 4. But now we have to express in this form. Send everything to the left hand side. You will have minus 1x plus 2y minus 4 is 0. Okay, and that will be your equation of the line which is perpendicular to A, B, and passing through C, as you can see right here on the diagram. Now let's move on to the next question. So solve the equation this for x between 0 and 180. So let's try. So here we have 15 But here we have cos, but we realize that we can change sine square x to cos. How? You change that to 1 minus cos square x, right? That will be 13 plus cos x. Because we know that sine square x plus cos square x is equal to 1. So sine square x is 1 minus cos square x. Okay, so here we have this, expand, you have 15 minus 15 cos square x equal to 13 plus cos x. Now send everything to one side, you will have 15 cos square x plus cos x. Here we have 13, here we have minus 15, should be minus 2 is 0. So now if you can see, we have a quadratic equation, right? Now again, if this is too hard for you to see it, we can do something. We can let u equal to cos x. You will see that will be 15 u square plus u minus 2 is 0. So now it is pretty simple. We can factorize. What is 15? 15 is 5u times 3u, right? 2 is 2 times 1, 2 times 1. To get plus 1, we have to have plus 6 minus 5. Because we always multiply in this way, right? That will be plus 6u, and then plus minus 5u should be plus 1. So that will be your factorization. For the first one, u will be minus 2 over 5, and u here will be 1 over 3. So simplify. Again, we're not trying to find u, we're trying to find the value of x. U is given to you by cos x, so cos x is minus 2 over 5, or cos x 1 over 3. Now when cos is negative, we know it should be in this quadrant and in the third quadrant. This is the angle of 180 minus theta. This is 180 plus theta. Now theta is not your answer, it is just a proxy that I'm using right now to find the value of x. For example, theta is equal to what? Cos inverse of the positive value of this. Okay, it is not the value of x, right? 2 divided by 5 should be 66.4. Now x will be given according to the quadrants. X is 180 minus theta, so 180 minus 66.4, that should be 113.6, or should be 180 plus theta. That will be 246.4. Okay. Now for this one, pretty easy as well. Now we know it is in the positive in the first quadrant and in the fourth quadrant. This is 360 minus x, and this is x directly. Now, whenever it is positive, we can find the angle directly. So cos inverse of 1 over 3, this is x, should be what? 70.5, but also 360 minus x should be 289.5. Okay, so here you go. So finally we will have 4 values for x. As you can see, we have this, and this, and we have to check if they lie between the values of 0 and 180. So let's check. So this one is too much, this one is too much, so we have x is 70.5 and then 113.6. And this is because of the domain we are given here for the values of x. Let's move on to the next question, part 4. Sketch the curve y equal to 2 sin x. So pretty easy. Again, we have a trigonometric curve, so we have to use a table of values, right? That will be my x value, my y value. I will begin with a value of 0. And what interval can I choose? To choose the interval, I look the value in front of x, it is 1. So it will be 90 degrees divided by 1, because here we have 1. So my intervals will be 90 degrees, which is same as pi by 2 radians. That will be pi by 2, and that will be pi, 3 pi by 2, and that should be 2 pi. Let's find the corresponding value of y. So replace. Here we have radians. 2 sine of 0, that will be 0. 2 sine of pi over 2, that should be 2. 2 sine of pi should be 0. 3 pi over 2 should be minus 2. And finally, 2 pi should be what? Should be the value of 0. Okay, so this will be the table of values for which I can sketch my curve. That will be the y-axis, and that will be x-axis. So here we have 0. We can have pi by 2. We can have pi over here, 3 pi over 2, and that should be 2 pi. And here we have the value of 2 and minus 2. Again, you will have to use a pencil for your sketch, right? Now the first point is 0, 0, right here, and then here we have this 2, and that will be 0 as well. That should be minus 2, and then 0. Try your best to join them by a smooth curve. Okay, so it's not that great, but you get the idea. Try your best to make it smooth as possible. That should be y, 2 sine x. That is your curve sketch for part 1 of your question. It's only 1 mark. Now for part 2, by adding a suitable straight line to your sketch, determine the number of real roots of the equation. So pretty easy. Let's have a look. So we have the equation here, 2 this sine x equal to this minus this. Now, so we have to understand, why did they ask us this question after number 1? So obviously we have to use something here as well. Now we are given that y is equal to 2 sine x. Okay, so if I rearrange this, let's see, if I write this 2 sine x times pi is pi minus x. What is this one? Same, so it is y, this is equal to this minus this. So if I send this over here, that will become minus 1 over this x and plus 1. So as you can see, we have to draw this line. This is a straight line on the curve and see how many solutions do we have. For example, you can always make a table of values to see what happened. You can see the gradient here is negative, so you'll be going in a downward direction. So let's try. So let me first make a table of values. So I have 0 here. That should be, if this is 0, that will be 1. And you have pi, for example, that should be 0. And if I have 2 pi, that should be what? So 2 pi, that should be minus 1. Right. Just replace back, this is the x value and the y value. Replace in the equation, you have to find the corresponding y value. Now I can sketch. So 0, 1 should be here. That's the first point. Pi 0 should be right here. And then we have this should be minus 1, should be right here. Now if you were to join all those 3 points, you will see the direction of the line. Again, it is only a sketch, doesn't need to be exact, but you get the idea of what's happening with the line. Something like this. This is my line. Great. Now, this is part 1 by drawing the line, and you have to find out how many roots do we have. The roots is the points of intersection. So by observation, you can see here we have 1 point, 2 point, and 3 point of intersection. So you can write number of roots according to the graph is 3. So I hope that was very clear. At first, we have to realize that they are asking us this question after this one. So usually we have to use this one to find out what can we do from the graph. So we realize we have this equation in part 1. We have something here which resembles this one. We rearrange. This is exactly this one. We place and make y become subject to form a equation of a straight line. So once you have this, you make a table, you plot your line, you find the number of points of intersection, and that will be your number of roots. Let's move on to the next question. A curve have equation y. This is the curve y. Okay. Now, what can I do here? As always, I like to rearrange. So I will have x minus 3 power minus 1 and plus x. So first thing I have to find dy by dx. So how would you find dy by dx? That will become first multiply by the power, then minus 1, that should be this, and plus 1. That will be minus 1 over x minus 3 square plus 1. This is for dy by dx. Now let's find d2y by dx2. So continue here. First multiply by the power should be 2. X minus 3 minus 1 should be this, and that will become 0. So you can rewrite this as 2 over x minus 3 cube. That is part 1 and part 2. Now part 2 of the question, find the points, find the coordinates of the maximum point A and the minimum point B. So let's find that. So what do we know? At stationary point, what happens? We know that dy by dx have to be 0. So dy by dx is given to you by 1 over this plus 1 have to equal to 0. Now we can send this over here. For example, you will have 1 over x minus 3 square is 1. Then we can cross multiply. You will have is 1. Solve. X minus 3 should be plus minus 1. X minus 3 should be 1. Or x minus 3 should be minus 1. So x will be 4. And x will be the value of. So minus 1 plus 3 should be 2. So now we have to find the corresponding value of y. So when x is 4, what is y? Replace back in your equation here. So 4 minus 3 should be 1. 1 divided by 1 is 1. 1 plus 4 is 5. Right? This is one of the points, 4 and 5. And this one, 2. So 2 minus 3 is minus 1. That will be minus 1. Plus 2 should be 1. So this is the other point. So now we have to know which one is the maximum point or the minimum point. So we have to use d2y by dx2, which is this one. Right. So d2y by dx2 when x is equal to 4 is what? Right, let's see. That will be 2 over 4 minus 3 cube. That should be 2 over 1 should be 2. Now since it is positive, it means that the point 4, 5 is a minimum point. So A is a maximum point, will be this one, 2, 1, and B will be the minimum point. So the idea is pretty simple. So once you know one of them is a minimum point, the other one will become the maximum point, obviously, right? That's how we do this. Again, you cannot have two minimum points in this kind of curve. So that will be your question, part 2, for finding the points of stationary points and then finding its nature to know which one is which. A curve have equation y equal to f of x. It is given that f prime of x is equal to this. Okay. Now f prime is simply dy by dx is given to you by this. Now part 1, we have to find the set of values of x for which f is increasing. So f is increasing when f prime of x is more than 0. So 3x squared plus 2x minus 5 more than 0. Now we have solved this kind of question many times before. We can just find the critical values first. That will be 3x squared plus 2x minus 5, equate that to 0. Then we can factorize. That will be 3x times x, 1 times 5. To get plus 2, we have to have plus 5 and minus 3. X will be minus 5 over 3. X will be the value of 1. That will be minus 5 over 3, value of 1. Now because it is positive 3, the shape of the graph will be something like this, right? Now this is the line 0. We're looking for values more than 0, so above 0 it will be this side and this side. So obviously it is the values which is less than 5 over 3 and more than 1. So these will be the set of values of x for which f is an increasing function. Now part 2, given the curve passes through the point this, find this. So pretty easy. So to find this, we have to apply integration on f prime of x. So let's do that. That will be what? That will be 3x squared plus 2x minus 5 dx. That will be x power 3 plus x squared minus 5x plus c, right? So we have to find c by using the Pascal point 1, 3. So when this is 3, value of x is 1, that should be 1 plus 1 minus 5 plus c. That should be 3, 2 minus 5 plus c. 3 is equal to minus 3 plus c. So finally c have to be 6. From here, f of x is equal to x power 3 plus x power 2 minus 5x plus 6. Okay, that will be question part 2 into finding the value of f of x, which is just y, for example. How do you find y from dy by dx? By integration. So because integration is a reverse process of differentiation, that's how you find the equation of your curve. Okay, so let's move on to the next question. The diagram shows the function f defined between the values of x of 0 and 6. Okay, 0 to 6. Okay, now for the first part, it is this equation, half x squared, this one, from 0 to 2, right? As you can see right here. Let me mark this down so we know it is 2p's. At first, it is from 0 to the value of 2. And then from 2 to the value of 6, it is the other equation, which is this one. It is a straight line, right? Now what else? We have to state the range of f. So the range of f is the y value of f, the up and down value. So by observation, you can see the y value begins at the point 0. And it goes all the way up to which? To this value, right? So we have to find this value. So pretty easy. This is the value when the value of x is 6. So replace 6 will be here. You have half times 6 plus 1 should be 4. So this is 0 till 4. So the range is between that. So f is equal to 0 and 4 will be the range. Now the range can be written as f, or you can write y as well for the range. It is up to you to choose. You can write y or f for the range in part 1. Now for part 2, copy the same diagram, and on your copy, sketch the graph of y equal to f prime of x. So f inverse, sorry, not prime. This is f inverse. So let's I guess I will not try to recopy everything. So what I can do here is I can understand that what is the relationship between the graph and its inverse. We know this. It is simply the reflection in the line y equal to x. So let me draw this line first. So let me try that. So I will have something over here. For example, let me measure this. So let's say this is 1. And there should be 1 over here as well. So they will join in the middle. Some over here. So if I join 0 to this line, that will be what? That will be my line y equal to x. So this is my line y equal to x. Now we understand that it is only a reflection. Again, it is only a sketch. Doesn't need to be exact. We can all kind of freehand this if you want to. So from what we can see, this part here should be something like this. Try your best with a pencil, obviously. And this part here should be, let's measure. That should be about 1.1, so should be somewhere over here. And join this one to this one. There you go. So this will be somewhat the y equal to f inverse of x. The main thing here we have to understand is it is a reflection in this line, and then we can use that to just reflect this one on top of each other. That will be part 2. Now for part 4 of the question, so part 3. So I guess we also can check something because we want to know if we actually touch over here, if the scale is correct. Okay, so when the value of x is 2, the value of y is what here? I think it's okay because it seems to be exactly matching. We don't need to check. It is exactly matching. That will be the 0.11. This is 2, 2. Seems to be that way. Let's check. So that will be 2. Replace, you will have half times x squared is 4, is also 2. This is 2. This will also be 2. Okay, anyways, it meets right here as well. Now, what's next? Part 3. We have to obtain an expression for f inverse of x, given the set of values of x for each expression. So pretty easy, step by step. From 0 to this, what will be f inverse of x, right? And from 2 to this, what will be the function f inverse of x? So one by one, here we have to do let y equal to half x squared. X squared can be 2y, x can be root of 2y. So here we have f inverse, it is in terms of x, that will be root of 2x. Now for this one, it will be let y half x plus 1. Half x will be y minus 1. X will be 2y minus 2. So finally, we can write down f inverse, it is in terms of x. That will be 2x minus 2. This is defined for this domain, and this is for this domain. You will have this function f inverse. Let's move on to the next question. The diagram shows a rhombus. Okay, A, B, C, D. So A, B, C, and D is the rhombus. And the points P and Q lie on the diagonal. As you can see here, we have a diagonal, and the point P and Q lies on the line. Great. Now, what do we know? Now, AC is such that BPD is an arc of a circle, center C, and BQD is an arc of a circle, center A. Okay, fair enough, as we can see on the diagram. Now, each side of the rhombus has length 5. This is 5, 5, 5, and 5. And angle BAD is 1.2 radians. So this angle here is 1.2 radians. Now we understand if this is 1.2, this also here will be 1.2, right? That makes sense, right? I hope that makes sense because it is the same, right? Now part 1, we have to find the area of the shaded region. So let's do that. I guess it is kind of interesting. It is not too bad. We just have to kind of play with the shape, I guess. So what can we do here? We can try to do this. We can first break it down into half. So if we do this, what happens? Okay, so what I propose is we can first find the area of this one. Right? And then we can just multiply by 2 to find the area of the whole thing. Right? So let's do that. How would you find the area of this one? So pretty easy. We can first find the area of sector CBD. So find the area of sector, this one, CBD. That will be half, all square, and the angle is 1.2. That should be what? Half times 25 times 1.2, that should be 15. The area of the whole thing is 15. Now, to get just this one, we have to minus the area of the triangle. So minus area of triangle CBD. So triangle, how do you find the area? We can use the formula, obviously. Half sine of the angle in between and times the two sides, that will be 25. So half times sine of 1.2 times 25 should be 11.65. Now this area will be what? Will be the big thing minus this one. So 15 minus 11.65. That'll be 3.35. Now this is not your answer yet because we also have to find this side. Now again, we understand that this side and this is the same, so multiply by 2. 3.35 times 2, that should be 6.70 centimeters square for the area of that region BPDQ. Okay, now what else? We have to find the length of PQ. So where's PQ? PQ is this one. Alright, so how would you find the length of PQ? We can observe and see what can we possibly use here to find that length of PQ. Okay, so something we do realize that this is the radius is 5, and if we can understand this, this will be this whole thing here, for example, is also 5 because it is the radius, right? So 5, 5, 5. Okay. Now we can do something first. We can, for example, I can find this length. Let's just think. I know this whole thing is 5. I can find this length. So here. So we take 5 minus this one. It will give me remaining this one. Now we can understand that this one is the same as this one, right? So this together will be the length of PQ. So let's do this, right? So let's find the length of this one. Let's call this x. Let's find the length of AX. How would you do this? So pretty easy. If you observe here, we have a triangle. A, B, and X. X is here, A is here, and this is B. This is 5. Now, this is 1.2, but half of this will be what? 0.6. This is 90. We can find this by using the Socrates theorem. So let's do that. This is my A side, this is my H side. We have to use cos. Cos of 0.6 is equal to A side AX over 5. So AX will be 5 times cos of 0.6. That will be 4.127. Which means if this is 4.127, what is this one? Will be 5 minus answer. That should be 0.87332. So now we understand that this is the same as this. So PQ will be 2 times this. So PQ will be answer times 2. That should be 1.75 correct to 3SF. And that will be a question in relation to circular measure. So let's move on to the next question. A GP has first term 100, so A is 100, and the sum to infinity will be 2000. Find the second term, pretty easy. So we know in GP we have A and the common ratio, so we have to first find the value of R. So pretty easy. Using this, sum to infinity is equal to A over 1 minus R is equal to 2000. Right, so 1 minus R should be A divided by 2000. From this, we realize that R will be 1 minus A is 100 over 2000. That should be what? 1 minus 1 over 20. That should be 0.95 for the value of R. Now, when we have the value of R, we can find the second term. So second term will be A R n minus 1, which is A is 100, 0.95, n minus 1 is just 1. It should be 95. That is part 1 of the question. Now for part B, we have an AP has the third term is 90 and the fifth term is 80. So let's write this down. So the third term is 90 and the fifth term is 80. Okay. Now we know this is an AP. So for AP, we know that the n term is given to you by A plus n minus 1 times D, and the sum of the first n term is half n 2A plus n minus 1 times D. Okay, great. So first question, we have to find the first term, which is a, and value of d. So we have to use these two values, right, logically. So replace back in your equation. When n is 3, that will be 90. So that will be this. A we don't know, n is 3 minus 1 is 2d. That is my first equation. Now for this one, when n is 5, that will be 80. 80, a we don't know, n is 5 minus 1 is 4 times d. So a will be 90 minus 2d. Replace in this one, you will have 80 is equal to 90 minus 2d plus 40. So this will give you what? Send this over here, that will give you minus 10. That will give you the value of 2d. So d will be the value of 5, which means a will be the value of. So now for part 2 of the question, we have to find the value of m, given that the sum of the first m terms is equal to the sum of the first m plus 1 terms. So pretty easy. For part B, we're given that this is an AP, so we just have to know the sum of the first m terms is equal to sum of the first m plus 1 terms. Okay, so let's see what can we do. Now we do understand that the sum of the first n term is given to you by half times n times 2a plus n minus 1 times d. So we just have to use this formula here and then form this equation. So let's see, what do we have. On this side you will have half times m 2a, that will be m minus 1 times d is equal to half times m plus 1 times 2a plus m plus 1 minus 1 should be just m times d. Now we can simplify. Half will cancel out, right? And then let's expand. You will have 2am plus dm times m minus 1 is equal to m plus 1 times 2a plus dm. Now we can still simplify. Let's see what happens. 2am plus dm square minus dm is equal to 2am plus dm square and then plus 2a. And what else do we need to know? 2a, and then what do we have? Plus dm. So simplify. So here this and this will cancel out, and then this and this will cancel out. So you will have minus dm will be 2a plus dm. So let's send this over here. Why not? You will have 2dm will be minus 2a. Now we know the value of what? So 2 obviously we can cancel out. You will have dm will be the value of minus a. So m will be minus a divided by d. Now a is 100, so minus 100 divided by minus 5, that should be 20. M will be 20 for the value of m. Now for part 3, we have to find the value of n for which the sum of the first n terms is 0. So pretty easy. First n terms have to be 0. So just replace back in your main equation over here, then we can find the value of n pretty easily. That will be half times n 2a plus n minus 1 times d is 0. Of course, we can just cancel out those two. So how do we cancel? We can first divide by half on both sides. This will go away. Divide by n on both sides. This will go away. Then you will have 2a plus n minus 1 times d is 0. So simplify. N minus 1 times d will be minus 2a. So the value of d, so n minus 1 should be minus 2a divided by d. So finally n will be minus 2a divided by d plus 1. So let's find out. That should be minus 200 divided by minus 5 plus 1. That should be what? Should be 21. So let's double check. I think it's not 21. I made a mistake. It's 41. Because this is what? Minus 200 divided by minus 5 should be 40 plus 1 is 41. So 41 for your value of n. So finally n will be 41. And that is your question in relation to AP and GP. let's move on to the next question. The diagram shows a triangle OAB. So here we have OAB. Good. In which the position vectors of A and B are given to you by the following vectors. Good. Now C is a point on OA right here, such that OC is P times OA, where P is a constant. Great. Now first thing, we have to find the angle AOB. So from O, go to A, and O, go to B. So we have to find the angle in between. So pretty easy. We can use the scalar product. That will be vector OA. That will be 2, 1, minus 3, dot, minus 3, 2, minus 4, equal to, the magnitude should be 4 plus 1 plus 9. And this one, 9 plus 4 plus 16. Cost of the angle, 0. Solve. That should be minus 6 plus 2 plus 12. That should be 8. Because dot product is pretty easy. 2 times minus 3 should be minus 6. Plus 1 times 2 is 2. This plus 12. Divide by root of 14 and root of 29 should be cos of O. Now O will be cos inverse, so A divided by root of 14 times root of 29. Here we can use degrees. Cos inverse of that will be 66.6 degrees. That is part 1 of your question. Now for part 2, we have to find BC in terms of P and the vectors I, J, K. So where's BC? So from B, going to C. So pretty easy. From B, we can first go to O, and from O, we can go to C. Right. Now we know that OB, it is in this direction. So BO will be in the opposite direction. So the sign will change. So you will have 3, and that will be minus 2, 4. Now OC, as you can see, OC is defined by P times OA. OA will be 2, 1, and minus 3. So simplify, that will give you 3 plus 2P I. That should be P minus 2J, and finally should be 4 minus 3P K. In terms of I, J, and K, and then also P for the value of vector BC. Now, for part 3, we have to find the value of P for which BC is perpendicular to OA. So BC is at 90 degrees to OA. So pretty easy. If it is 90 degrees, it means the scalar product will be 0. So here we have the we have to find the side BC first. BC, we found this already here, so we can write this as 3 plus 2P, P minus 2, and 4 minus 3P. Dot product of OA given to you by 2, 1, minus 3 should be 0 because it is perpendicular. So now we just have to perform scalar product and solve for the value of P. So 2 times this will be 6 plus 4P. Plus this time this should be P minus 2 plus that should be 9P minus 12, that should be 0. Simplify. 4 plus, so 4P plus 1P plus 9P. So 4 plus 1 plus 9 should be 14. 14P. That should be what? Send this over here. So 6 minus 2 minus 12. That should be 8 over here. Minus 8, send this over here, become 8. So P will be 8 divided by 14. That should be 4 over 7. That is your value of P for part 3 of your question. Okay, so let's move on to the next question. The diagram shows parts of the curve y equal to 9 minus x cubed, okay, and also the curve y equal to 8 over x cubed. So now we can rewrite this as 8x power minus 3, right? And then we have the points of intersection, which is P and Q, as you can see right here, okay? Now the x coordinates of P, Q are A and B respectively. So A and B, as you can see. Now part 1, we have to show that x equal to A and x equal to B are roots of the equation this. and then solve the equation, hence finding the value of a and b. So pretty easy. So how would you usually find the points P and Q? So you understand that P and Q, they are points of intersection, where it is where they meet or where they cuts, so we have to solve them simultaneously. This is my equation number 1, my equation number 2. On one side I have 9 minus x cubed. On one side I have 8 over x cubed. I can just cross multiply to see what happens, right? That will be 9x power 3 power 6, and that should be the value of 8. Let me send everything to one side. You will have x 6 minus 9x power 3 plus 8. That will be 0. So as you can see, this is shown as required, shown as required. Now we have to solve this equation, and hence finding the value of a, n, and b. So pretty easy. So what can I do here? I can let u be x power 3. For example, that will give you u square minus 9u plus 8. Now we can factorize. U square is u times u. 8 is 8 times 1. To get minus 9, we have to have minus 1 minus 8. So u will be 1 and u will be 8. Again, u is x cubed, will be 1, x cubed will be 8. From here, x will be 1, x will be the value of 2. So this is 1 and this is 2. Now next one. Hence find the area of the shaded region. Pretty easy. How would you find the area? So first step, let's find the area of the whole region. Right? That's the first step. That will be area under the first curve on top, that is 9 minus x cubed, respect to dx, limit is 2, 1. That will be 9x minus x power 4 over 4. That should be 2, 1. So replace 9 times 2 is 18 minus 16 divided by 4. That should be 14. And then we have to minus, that should be 9 minus 1 over 4. That is 8 over 3 quarter. So we will have the value of 14 minus answer. That should be 5 1/4. So the area of the whole thing here is this. Now if you want the area of this region, we have to remove this one, right? Cancel out this area. Now what is this area? It is simply the area below the second curve. So how do you find area below curve? You will use, obviously, integration. That will be 8x power minus 3 dx, this one, right? And limits is 2 and 1, same thing. That should be 8 here. Increase the power by 1, should be minus 2, divided by minus 2. That should be 4 here, and you will have minus 4 over the value of x squared. Limits of 2 and 1. So first one will be minus 4 divided by 4 should be minus 1. That should be minus 4 over 1. That will give you minus 1 plus 4. That should be 3. Okay. So the area of this region that we don't need is 3. So obviously the top one will be the big one, 5.25 minus 3. That should be 2.25 units square for the area of the region. That is part 2 of your question. Now part 3, the tangents to the curve at C. So the tangents to the two curve at x equal to C, which is between the value of a and b, somewhere over here, we will have a tangent to the two curves. They are in the same direction, right? So here we have to find the value of C. So now we understand that if they are in the same direction, it means the gradient of one line on one tangent will be the same as the gradient of the other tangent. So now we know that gradient of tangent is what? It is simply the value of dy by dx. So gradient of tangent is dy by dx. So now for the first curve, we know we had what? We had y equal to 9 minus x cubed. What is dy by dx of this one? That will be 0 minus 3x squared, which is minus 3x squared. Now for the other one, we know we had y equal to 8x minus 3. dy by dx should be minus 24x power minus 4, which is equal to minus 24 over x power 4. But now, we are saying that it is at the point C, which is this x value, such that they are in the same direction, which means the two gradients have to be the same. So we equate them. On one side we have this, have to equate to this side. Right? Now what do? We have to solve for the value of x. We can divide by minus 3, that will be 1, that should be 8. Then we can cross multiply, you will have x power 2 times x power 4, and that should be 8. Okay, now what is this one? By the laws of indices, because they have the same base, we can add the top, that should be x power 6 will be 8. So finally, x will be 8 power 1 over 6. So let's see if that is an exact value or not. So power 1 over 6, that should be root 2. Yeah, root 2. Again, we can simplify, obviously. Let me show you. So for example, I know that 8 is equal to 2 power 3. Right. Replace, you will have 2 power 3 power 1 over 6. That will be 2 power 3 times 1 over 6. That will give you 2 power half, which is root 2. So x value will be root 2. So hence, that value of c here was root 2. Okay. And that will be your question. Part 3. Well, we have to use the understanding of tangent is the same thing as dy by dx. And this is the same value. So this parallel means they have the same value or they are equal to each other.